Here we are going to solve a question on indices. It says solve for x in the following equation. So you have 5 raised to the power or raised to the exponent of minus 5 minus open bracket 5x plus 8 equal 25 raised to the exponent of 2x plus 5. Now here we need to know the rules of indices. When you multiply it and the base is the same, you just add the exponents. When you divide in, the base is the same, you subtract the exponents. When you have powers raised, you just multiply the exponents. If you have a negative exponent, it comes down as a denominator. If it's down as a denominator, it can come up as a numerator. So you have to know these laws of indices. And here you have the vice versa. Any value raised to the power of 0 is equal to 1. A times x to the 0 is like a times 1, which is a, because x to the 0 is equal to 1. Here you have the radical sign can be converted into a fractional exponent. So the power of the base under the radical sign will form the numerator, and the value of the radical sign will form the denominator. For example, you have the square root of x. There's an invisible 2 out there, and there's an invisible 1 above the x. So that invisible 1 will become the numerator, and the 2 will become the denominator. So the square root of x can be rewritten, or you can write it again as x to the exponent of a half. Cube root, x to the exponent of a third, etc. So now, knowing these rules, we can approach this question, and here we are going to apply the powers raised rule. If you have a base raised to a power and raised to another power, you can multiply the powers. So if you notice now, you have a base of 5 on the left and a base of 25 on the right. That was deliberate because 5 squared is 25. So you keep the left side as is, 5 raised to the negative, open bracket 5x plus 8. But then that 25 there now, you can write it another way. 25 can be written as 5 squared. 5 squared is 25. Okay? So we can write 25 as 5 squared. Okay? It's the same. Now, writing 25 as 5 squared, now we are seeing that we have a base of 5, and we have a power, let's call it n, and we have another power or exponent, let's call it m. So according to this rule, we can multiply them. Those two exponents there, we can multiply them. They call them powers raised. So that 2 can multiply to that 2x plus 5, just like how n can multiply to m. So in another step, we keep the left side as is. As you can see, I put a minus 1 in front of the bracket. If you don't see a coefficient, there's a minus, there's a 1. In this case, it's a minus 1. So it must be for good reason I put it there. Okay, so let's we'll come back to it. Now we are going to apply this in the rule of indices, powers raised. We're going to multiply 2 by this power. As you can see, 2 is multiplied by the entire binomial. 2x plus 5 is a binomial because it has 2 terms. We have to bracket it because 2 have to multiply to both the 2x plus the 5. So we keep it outside of the bracket. So now you realize now 5 is raised to this exponent and is equal to that same 5 is raised to that exponent. So therefore, the exponents must be equal to each other for that to be equal. It's like 5 to the cube is equal to 5 to the cube. Okay, so 3 is equal to 3. Okay, 5 to the 8 is equal to 5 to the 8. So 8 is equal to 8. So those two exponents must be equal to each other. So due to the fact that the base are the same and you have an equal sign there, we can equate the exponents. So minus 1 open bracket 5x plus 8 is equal to 2 open bracket 2x plus 5. Again, this was deliberate. If I have to construct a question like this and I put a 6 there, can somebody guess what number I will have to put there for this to work, like how this question is operating? Correct. If I put a 6 there, I can put 36 there because 6 is a 46. 6 squared is 46. If I put a 7 there, I can put a 49 there. 7 raised to the power of 2 is 49. If I put a 2 there, then I can put several numbers there. For example, I can put 4, 2 twos are 4. I can put a 8, 2 raised to the power of 3 is 8. I can put a 4, 2 raised to the power of 4 is 16. I can put a 5, 2 raised to the power of 5 is 42, etc. All right?
I have a question.
So therefore, now I will be constructing one like this. I can use a 6 and 46. I can use a 3, which is, I can use a 9, 3 and 9, 3 and 27, 3 and 81, etc. Okay, now you have to do that. Change the number, the bigger one, with its power, multiply the power, and then equate. Once the bases are the same, you equate the exponents, and then you start to solve for x. As you can see, that -1 was deliberately put there to show that you're multiplying by -1. -1 by 5 is -5, and -1 by 8 is -8. 2 twos are 4, 2 fives are 10. Now you have a -5x on the left side and a positive 4x on the right side. So let us cancel all that -5x. Okay, so that we can have all x's are positive. So to cancel out the -5x, you have to add 5x. If you add 5x on the left, you have to add 5x on the right. So that -5x and that 5x cancels out. You are left with -8. And 4x plus 5x will give us 9x. Okay, look, it is written there, 9x plus 10 on the right side. Now we've got to cancel out the 10. A plus 10 can be cancelled out by a -10. If you subtract 10 on the right, you've got to subtract 10 on the left. Okay, so 10 minus 10 is 0 on the left. So there is no 10 anymore on the right. But then on the left, now you have a -8 minus 10. A -8 and a -10 will bring you further negative, -18. And now to cancel out 9, which is multiplying to x, you divide by 9 on both sides. And then you have 9 divided by 9 is 1. So we have 1x, x. -18 divided by 9 is -2. So finally, x is equal to -2. If you have time, you can prove your answer by substituting -2 into the place of x in the original equation. So if I put -2 there, and I raise up 5 to that number, I should get the same answer. Okay, let's go to the original. If I put a -2 there, and I work it out, and I raise up 5 to that number, I should get the same answer if I put a -2 there and raise up 25 to it. You can prove your answer to see if it is correct. What do I mean by that? Let me just write it. And that's an exercise for you to prove your answer. Proof of answer. That's optional. You don't really have to do that. Okay, let's put back the 25 inside there. So if I substitute -2 in the place of x here and work this out, the number I get here is supposed to be equal to that same number when I put -2 there. Okay, those two numbers should be the same. So you can prove it as an exercise to see if the left side is equal to the right side.